All right, what do we need to see between those two problems?
I have a question about when you use what formula.
Okay, is this pertaining to number 1 or number 2?
For number 1.
Okay.
So for the third bullet point, when it says you make $2 million and you pay the percent and it's compounded weekly, how do you know that you have to use the formula that uses P rather than trying to find the recurring value?
All right, perfect. So that's a great question. So this is homework number 6, number 1. I don't recognize that voice. It sounds like Jackie, but I'm not sure.
It's Olivia.
Oh, just kidding. So the question was, how do we know how to use which formula, right? And what happens is that even though it could be a little bit vague at times, the way to think about it is if something's missing, that's normally the way you can tell if you have to use a different formula. And don't worry, I know that's a very vague answer. In addition, though, if there's something that isn't explicitly stated, then you know that it can't be anything else. So let me just break down. I know that Olivia asked for letter C specifically, but let me just write down A, B, C really quick here. A, B, C, and D. So the first one, remember, this is just like, this class didn't do it so much because this class has a better handle of being able to distinguish the problems. But now that you have all the problems stacked up like that, and you have to read it one by one, it may be helpful to, instead of just jumping right into a problem, to list them out like this, A, B, C, D, and tell yourself what they are. So the first one would be cost, revenue, profit. How do you know that? Remember, there's always 2 sets of things, and it says, in this case, marshmallow. Each marshmallow can be produced, can be sold for however much. Second one is a lease. D is a monthly deposit. So you just know that this is some kind of constant per month. Sorry, I'm going to mute whoever's watching TV in the background. Not that I don't mind, it's just a little loud. Okay, and then C, here we go. So this one, it says that it's compound weekly, and you know that it's going to use a compound period. Now it's just a matter of whether it's this one. Oops. Or this one. Oops, future value. And I'm going to already tell you, because you guys seen it in the answers already, that it's the first one. And the primary reason you're going to use this one and not this one. And the primary reason is that even though there's a compound period, there is no notion that you're putting the money away per week. And that's how you know. So I'll write that here too. No notion. That money is deposited. And I'll even be more specific here. Deposited per compounding period. I guess that's more vague actually, right? Because it can rely on whether the compounding period is weekly, annually, semi-annually, monthly, quarterly, or daily. So remember, the biggest thing between these two, or if you happen to have your formula sheet out too, I forgot to mention that earlier, but that's okay. If you're looking at your formula sheet, remember the first row is all compound stuff, one-time deposit. The third row with the annuities are also compound period, but multiple deposits. Now, when you read this question, you want to make $2 million from an account paying 7 5/8% compounded weekly for 25 years. Did I say one-time deposit? No. So you might blame me and go, hey, you weren't specific enough. However, I definitely did not say that you're going to be making a deposit every week or every compounding period. And you kind of know that makes sense now that we're slowly getting to the flow of things, that these things, when I asked for your model, let me write this down here as a hint as well for people. When the model is asked, we, as in you guys, past or future students, we always represent per month. So in other words, the models are on a monthly basis, right? Which means that even if you did have a different compound deposit, in this case, like deposit weekly, that just makes it harder. Can I ask that question? Absolutely, right? You get the number per week and then you multiply it by 4 because there's 4 weeks in a month, and then you give me that number. I'm not going to do that. That just makes it way too, not difficult, just tedious. So I know that I took a long time to explain a lot of this, but I feel like this will help multiple students, especially if you're running into the problems and you're trying to figure out the components to build your model, list them out first, then attack them. Specific to this question, no, I didn't tell you that it's a single deposit. In addition, I definitely did not tell you, though, that it's going to be deposited per week or per compounding period. Does that answer your question, Olivia?
Yeah, thank you.
Absolutely. What other questions people have for number 1 right now?
Are you able to go over the part A, the cost revenue profits? For some reason, I got different numbers.
Absolutely.
For the C of X, P of X, and R. I got R of X, but C of X and P of X were different.
Okay, this is specific to number or letter A, sorry.
Yeah, 1.
Definitely don't recognize your voice, so thank you for asking. And
Terry.
I'm sorry, who?
Terry.
Oh, perfect. So, wait, what's happening here? All right, good. All right, so Terry's question was like, hey, the revenue, everyone should already get that because that's given to you right there. My question, though, is, do we get the slope correct? So here it is set up for you. So that should be 200 minus 95. Sorry, I'm not color coding. I'm just jumping right into it. 250 minus 100. And if I remember correctly, it should be 11.33. Do we get that at least?
Oh, maybe, I don't know. I did the same setup, but I got 1.43. So maybe I got it different. I don't know. I guess
Did you
that was it.
remember? No, it's okay. No, wait, I think I did it wrong. Hold on. I think that was an example. No, ignore me. Nope, sorry. Yeah, that was my fault. That was a previous example. I was working with a student. Yeah, it's 0.7. Do we get that at least? That was my bad. Sorry. The answer is 0.7. So the number 1 issue that people have if they don't get the slope is that they forget to put the parentheses around this. So mostly people forget to do that, because then what happens is that the numerator is dividing only by 250 instead of the difference between 250 and 100. And that's why the slope can be off. The other thing that I see students get incorrect is that they plug in this information incorrectly to get the cost function, right? And the other thing is that, I know I said this a couple of times, remember, if you are an algebra student that's proficient and you don't like using this method because you learned a different method like I did back in the day where you use the y equals mx plus b formally, and then you re-plug in, you solve for b, and you got to remember to plug in, you can do it that way. But this is for those that I've taught and your algebra background is either shaky or needs to be rehashed or whatnot. So remember, this one goes like this. Y minus, what is that, 95 equals x minus close parentheses. So that's 0.7 and then 100. Number 2 mistake that students make here is that they remember to write all this perfectly fine, but then they forget to distribute this way. So that should be minus 70, I believe. So it gives you plus 25. And then you add 95 over, and then that's how you get the cost function. Equals 0.7x plus 25. So there's that. And the profit function, again, most people mess this up because they forget to distribute the negative as well. So that's our revenue and cost. And I'm willing to bet what happens is that this is what, 1.25x, 1.25x. They write the minus correctly. They even write this correctly. But I personally suggest to add these parentheses. Let me use them a different color so that it stands out to you. So you know not only to subtract these two, this number goes negative. So I remember this is the algebraic explanation for it. But for those that need a quick, easy way to remember, it's the difference between the x's and then whatever your number here is, in this case 25, it's the negative version of it. And that's what you're supposed to use for your model. Actually, you know what, let me do that in orange. Okay, there you go. So there's two things that happen here that I see often, right? It's either this distribution in pink that they forget, and it's definitely this distribution in pink that they forget. And then sometimes students, they get panicky or whatnot, and they're pulling in random numbers. And it's hard to decipher because sometimes if they can't get the slope correct, then it all falls down. It all goes to, oh, that's a pentagon. It all goes to hell pretty quickly. So it's a little tough. It's just, you all know how to do this, and I'm confident you know, unless you skip this problem on this first exam, then you know, oh wow. Either way though, you've seen this before. It's just a matter of being a little bit careful or a little bit cautious, however you want to describe it. But those stars are the big points where students generally miss up from there. Is that okay, Terry?
Yeah, thank you.
You're welcome. What other questions for
Can we
number
go
one?
over the break-even point?
There you go. That's what I was waiting for.
Yeah, I
Number
wasn't
one.
the right. Yeah. Well,
Yep.
Thank you.
No, you're right. Yeah. Those I3, those are just lowercase Roman numerals. So you just label it 1, 2, and 3. Okay,
One.
good. Break even. So I was waiting for someone to say something about that. I know we haven't talked about it in a while, but we're gonna do it, right? So you know you have to set $0, but just in case people didn't realize this, because I'm not shocked, I'm just surprised no one's talked about it yet. So letter D right here, I'm gonna put a little, say, orange star right here. That's a constant per month because you're making monthly deposits, but you don't have to calculate those monthly deposits, right? It's not an annuity. It's just something that's happening per month. So it's 10% of the profit function. So if you don't have the model up already, whether you have it written down or you're looking at the, what do you call it? The answer on page 36 of my textbook, right? The model looks like this. So P of X, which is the 0.55X minus 25. All right, I'm just gonna separate the colors as well. Then you have a lease of 5,368.22. You have a one-time deposit, which is 297,688.82. So again, for those that are going, hey, where are you getting these numbers? Remember, they are in the answers. And then this is the part with part D with the orange star. So I'll draw another orange star here so that people can see. It's 10%, so that's 0.1 of our income. Our income, our only income, is the profit function. And I know no one said it, but I'm going to address it just in case, because perhaps people don't want to speak out loud. If, don't write this part down, if you distribute this negative 0.1, right? We talk about the very end right here. If in green, if you distribute this and then set this entire model equal to 0, you will still get the correct answer as long as there are no algebraic mistakes. So I'll say it one more time. If this last section right here is distributed by not 0.1, negative 0.1, right? Because of that negative right there. And then you set this entire model equal to 0 and you solve for it, you will get the correct answer. However, the way I have it in the solutions is to make myself a little bit easier, because you realize, let's use this color, that you have one whole of this parentheses and you have 0.1 of this black parentheses. So what's 1 minus 0.1? It's 0.9. Or another way to think of it is you have 1/10 of this parentheses, or you have 1/10 of your profit. Here you have 10 over 10 of the profit, aka 1. Well, what's 10 over 10 minus 1 over 10? 9. Oh, damn it, I just said it. What's 10 over 10 minus 1/10? It's 9 over 10, or 0.9. So let me just rewrite that really quick here. So 0.9, that's where it comes from. 0.55x minus 25. And then now you can combine these two numbers right here, because it's going to be a solve problem, right? This is equal to $0. So if you're doing it this way, this is the most common way I see students do it. So let me just add up these two numbers really quick. 5368, 5368, 22, 297, 688, 82. The student was asking about this the other night as well too. So that's 303,057.04. The last step that needs to be done now is to distribute this 0.9, right? So now your equation should look like the following. Let me use a different color. I'll use green. So 0 equals point, I already forgot what this number is, 9 times 0.55, which is 0.495x, don't forget the x, times 25, which is, 22.5. So this is still minus 22.5, minus 303,057.04. All right. I forgot, or maybe I didn't ask whose question this was. However, are we okay here? Do you want to take a moment to try to type this out on your calculator, anyone for that matter, and just make sure you get the correct answer? If you got the correct answer, but you're wondering why I had it at exactly 612,282 marshmallows, is that, remember, you have to round up to next whole number. And remember, this is different from regular rounding. You're just rounding straight up, going to the next number. I'll take a moment to pause to see if anyone else needs anything else. In fact, while we're pausing, I'll see if anyone's chatting a question right now. No, they're not. Okay. 30 minutes in. Okay, that's not too bad. If anyone's curious, normally when we do this in person, I wouldn't say that this always takes up the first full hour of going over these modeling problems, but it takes about at least 30 minutes, depending on the class, and then sometimes up to 45 minutes, depending on how much I bark about certain topics and telling people don't forget this, don't forget that, or me nagging about something that's like a super pet peeve that I don't want people to miss. That's supposed to be something that you've mastered already. All right, so I'm not hearing anything right now. What are the questions on number 1? Remember, we have 2 more follow-up questions right there if needed. If not, we can open to questions number 2 as well.
I have a question on part D. I'm still confused about it. I don't get how to do it.
For number 1 or number 2?
Or number 1, sorry, I know I'm going backwards.
No, that's fine. Okay, so part D, it's just asking for, this is how I explained it to the student that was asking last night.
I know, I asked
They were
last night,
saying,
I don't get it.
it was, where is it? A, B, C, D, right? So it says, let me read out the statement first. It says you want to take 10% of your income to deposit away every month. So that means that of the, let me use a different color here. Of these 3, A, B, C, D, right? What is making you money in the moment, right? In the moment of the month? Well, it can't be the lease. I guess I'll use this color. It can't be the lease, right? So the question is, okay, so for part D, first figure what makes you money? What makes you money now, right? So you're looking at this and you're going, okay, lease, that takes away my money, so that can't be it. Part C, as we mentioned earlier, right? That is something that's making you $2 million, but do you have that $2 million now? And the answer is no, because we're trying to put away money to reach $2 million. So it's not this either, okay? Can't be D because that's our question, so it has to be part A. Now, what was asked last time was, how do I know which function to use? Do I use the cost, the revenue, or the profit? Well, here's the thing, right? You only need to use the profit function if you ever see it in a model. I may have said that only once or twice, but let me scroll back down here and just put a note on that. So, note to all modeling problems. If cost, revenue, and profit are found, only the profit function goes into the model. Why? Well, think about it. If we're producing, say, I don't know, like napkins or something silly like that, right? The cost function here tells you how much it costs to make those napkins. The revenue tells you how much is being made. But the thing is that it's telling you just the money coming in. It's not telling you all the expenses that are being incurred. Therefore, the profit, being the difference between those two, is the perfect candidate to put in our model because it encompasses all pieces, cost, revenue, and profit, and it utilizes what we have to, or uses what we have to do in one piece in our model. Because say, like the student that was talking to me last night, they were saying, oh, is it the revenue? Is it a cost? Well, the thing is that, go back to the model really quick. If the revenue and costs were in there, that means instead of having these black parentheses expressions right there, you'd have to put R of X here and then subtract off another C of X there, which would be correct. It's just annoying because then it's 2 additional pieces you have to worry about. I'm gonna erase those really quick. There you go. So looking up here, you only need the profit function, that's 1, to put in the model itself. And now part D, when it says, hey, we want 10% of that, well, 10% is 0.1 or 10, however you want to think of it. 10% of the profit function, and that's just times P of X. or in this case, if you wrote out the entire expression, right, which is the 0.55x minus 25. Is that clearer?
Yeah, I got it. Thank you.
Perfect. All right. Other questions for number 1? We're still on number 1, so that's okay. This note, right, applies to all models that involve cost revenue profit. What about questions for number 2, if any?
You do.
That one was a little bit. Sorry, go ahead. I interrupted.
You do A, please.
Number 2, for A, all I'm looking for is something. It says your business has been consistent such that you have a positive income each month. You can use any variable, P for positive, X, it doesn't matter. But let P, or in this case, any variable. Well, you know what? Let me rephrase that. I'm going to put the word almost here. Almost any variable. Right? Because if you read the other questions, part B, C, and D, you can't use R because you have monthly deposits there. Same with C. And then D, you have another variable and you don't want to use the same variable twice. So that's why I'm going to say almost any variable. So let P be our income. And it says that it has to be positive. Now, this is me being super nitpicky, but when I say let P be our income such that P is greater than 0, this statement mathematically is how you represent the fact that in question A, and I'll read it out loud for everyone again. It says, your business has been consistent such that you have a positive income each month. And that's the assumption that no matter how much money you make, right, it's always going to be a positive income. You may make $1, which is terrible because then that makes your model overall go in the negative, but the income you make is always positive. So honestly, if you did this, it's okay, as you've seen me written in tests before. But what I'm really looking for is that give me that little extra oomph that if I give you a variable income and I take the time to tell you that it's positive, that you just have to tell me that it has to be greater than 0. That's all, right? Like you're not going to make -$6. You can have an outcome of -$6 because you didn't make enough money, right? You didn't sell enough things to outweigh your expenses. But we're not going to be in the business where I made -$6. You don't make -$6. If you don't make any income, you make 0 income. You have, in terms of expense reports, a negative outcome because you made $0, but you still incur expenses, if that helps. All right. What are the questions on part A for the number 2 for the model? And then the way I wrote it right here, just all of us right now present in class, not including what I have the answers in the textbook, right, is that this is just a little note here. If you're doing letter D, right, letter D, you need to know that the variable must be variable cannot be P because you already use P up there. And again, that's just a little bit being extra, quote unquote, if you will, right? I've had students, it's not the biggest deal in the world, and only a handful of students do this every year. It's like less than 5. But what they do is that they give me an X or a P in this case for letter A, and then letter D, they kind of tune out and they just use the same variable again. And of course, that's impossible because how can the same variable represent the income and what you're paying? What are you paying an intern? Yeah. All right. What are the questions for number 2?
Can you go over part C?
Absolutely. Part C. So did we get the setup correctly? Want to make monthly deposits. See, so here we go. This one, you know, it's an annuity right from the get-go because it says monthly deposits and that you want to make such that you have $500,000 in 30 years. This is part C. Did we get this as a setup, which is, I'm gonna just jump right into it. That's future value, $500,000, 0.0515, 1 plus 0.0515, minus 1 over 12, over 12. 30 years times 12 is positive 360. Did we get this setup at least?
I put 1 minus 1 plus, so I think that is probably it.
Gotcha. So the 1 minus is for the present value, and this one is future. So again, sorry, I didn't recognize that voice again. And anyone for that matter, right? You're doing these and you're going, damn, I missed it by just that much, just this little. Remember, I'm already telling all of you, you all are very capable of doing this. You showed me as such via homework, as well as your exams in terms of learning this stuff, right? What makes this tedious now is that I'm cramming it all together. So if you felt like you were, this isn't just the person that posed the question, but any of you that feels like, oh, this is a little bit too much, right? Take the time to list A, B, C, D, or whatever order you go, and label what kind of problem each of them are. And hopefully that will help solidify so that you don't go, oh, I had the wrong denominator type of thing, because you wouldn't have had that if you knew from the get-go that this was future or it resonated future in you or whatever the case may be. But yeah, if you punch that in the calculator, if you want to take a moment to make sure you get the right answer, that's it right there.
Thank you.
Anyone for that. You're welcome. And that's anyone for that matter. Okay, so I'll give you guys a moment for that. What about other questions on this one? I'm sorry if my chewing is loud too. If you really want me to stop eating, just let me know. Just like, hey, stop that crap. Make sure chewing my mouth closed like all our parents taught us at one point or another. All right. What are the questions for number 2, if any? And then as a friendly reminder to everyone, remember, this isn't the only way to reach me just to ask questions here, right? If you want a little bit one-on-one time, feel free to send me an email or a message via Remind, or if you notice that, remember my direct contact details are at the signature of every email, and you're like, no, I just want to know, I want your availability right now. Just let me know, and then we can always go over things together as well. All right, if I'm not hearing anything else for number 2, we're gonna move on. Now, if we pull up, I'm gonna switch my keyboard now to the Google Doc, right? We're on page 3. I'm trying to keep the problems in single pages. And again, if anyone happened to miss a lecture or missed at the beginning when I first introduced this Google Sheet, it's to avoid typing so that we don't waste time, right? Basically, so I don't waste your time by not having things typed up in advance. Also remember that the lectures, the MM just stands for mathematical modeling, and I always start off with 0 because I'm weird like that. So the first 2 pages, MM00 and MM01 respectively, were for last week. So you should be on page 3, and that says MM, or mathematical modeling 02. And this is our first example for the day. Now, we're not jumping right into a model right away. We're just talking about a concept right now that I'm going to include, and we're just going to really take it, not slow, but just be very explicit and, what's the word I'm looking for, intentional with every step to make sure people understand. Because normally when I'm teaching this, I go somewhat fast, but then, you know, in class you can kind of see what's going on, right? This, we're digital, yeah, you have this, you have resources. I made nice little YouTube videos, and had a whole bunch of help, and I couldn't have done it without their help and editing and all that fun stuff. So, cool. We got tons of resources, but still, you're hearing me right now, live action, and we just want to make sure that we get this in. So I'm going to call this part here just another form of income for our models, specifically summations. Okay. Number one, it says you are head of social media for our company. Okay. Research suggests for each social media post published, it will reach 2 new people the next day and thereafter. Suppose for the first day, the social media post reaches 4 people. How would you represent the growth and the total number of people reach? Okay, so I know there's a lot of jargon in there, but let's just break it down, right? And you can also, well, again, if I make sure I type these out in advance, you can write these down preliminary wise in your notebooks respectively. So I would circle the stuff or just write down as I'm writing down right now. So first day, oops, that is not how you spell first. What happens? In the first day, it reaches 4 people, right? So imagine 4 little stick people here. 1, 2, 3, 4, right? So where did 4 come from? It told me that the first day, your social media post, whatever your preferred method was, Facebook, Twitter, Instagram, YouTube. I guess a lot of people are into TikTok now because they're home and they got nothing better to do. I still haven't downloaded. I refuse to. There's just some things I'll just never download. That's one of them. And whatever your platform is, it reaches for the first day. Now, obviously, that's not true because if you have, well, sorry, it can be true. It's just not very real life in terms of like a social media for a company because obviously there's going to be a huge upsurge of people depending on followers and all that jazz, subscribers and all those things. But let's just imagine, if you will, that it's just for the first day. Now, if we read that sentence that starts with the research suggests, right? The research suggests for each social media post published, it will reach 2 new people the next day. What does that mean? That means that if we were to go to the second day here, and maybe some of you can already visualize this, right? I'll use colors. This person, because they were influenced by that post, they'll share it to 2 other people. There's their 2 people in light blue. And then maybe this person, they go, hey, here's 2 more people. And then this person goes, hey, here's my 2 people that I shared. And last but not least, this person shares another 2 people. So can we see the growth that's happening right there? We had 4 the first day. And then what happened? Then we had 2, 4, 6, 8 the next day. Now, if this pattern, if you will, continues, how much do we think we'll have on the third day without me having to draw every single pair out? Nobody? Somebody? Spend all day drawing these stick people. It's gonna be a lot, right? Hopefully you realize that.
Would it be 16?
I think so. Let's see. 4, 8, so that's 2, 4, 6, 8, 10, 12, 14, 16. Yes, it is 16. And then imagine a 4th day, and then a 5th day, and then so on and so forth, right? And then I'm gonna do ... Thank you for answering, whoever that was. And so what's happening, right? How did we get 16? Well, there's 2 ways to go about it. You could count all the people, right? Or you just realize that you can count in pairs for each new person that arrives, right? So it's, 2, 4, 6, 8, 10. Or you can think of it as multiplying, right? However, my I want to call your attention to realize that there's two numbers here, right? So I'm going to scroll down just a touch, but still leaving this picture here, and I'm going to write it down on the far right side of our page here, is that there are two numbers here. We were given two numbers. What were they? They were 4 and 2. Okay, so I want to bring that to your attention first. Second of all, I might ask, oh, how did we get 16? Well, you just multiply it by 2, right? 4 times 2 is 8. Maybe I'll write that. I want to use this color. So 4 times 2 gives you 8, and then times another 2 gives you 16. And then the fourth day, if you go times 2, what do you think you'll get? You get 32, right? Let me just write that down really quick. And the trend will continue. Okay, it's like, cool. But what if I give you really huge numbers? You don't want to be multiplying like this all the time, right? And you want to do this in an algebraic way that seems way more efficient, right? Less strain, less tedious work, and whatnot. So my question for you is that now that you kept in mind the two numbers that you were given and how we have increased each time, my question to you now, is there a way to represent the numbers 4 and 2? 4 and 2. You know what, let me write this in navy so I can match. 4 and 2, 4 and 2, 4 and 2, 4 and 2. So can you give me the numbers so that whatever happens between 4 and 2 equals 4? Let me write that in black, actually. Equals 8, equals 16, equals what will be 32, right? Anybody have any ideas?
For the first one, is it just you would do 4 minus 2? This is Marisa, by the way.
Cool, Marisa, thanks for answering. So yeah, you could do 4 minus 2 for the first one, which will give you 4. I mean, give you 2. The thing though is that we want it to equal 4, and if we put a subtraction in between all of these, it could work, but then we need something else in addition to subtraction, right? Because if we get 4 minus 2, for the first one, we got to get 2. If we do the subtraction, let me do this in different colors, sorry. So say, I guess my question is, what pair of things can I put in here, whether it's a subtraction, a plus sign, a multiplication, as well as putting powers or something will give me the results there. So subtraction is a good way to start because you go, well, if I subtract these two, then I get 2, and 2 squared is 4. And then if I subtract here, I get 2. 2 to the 3 is 8. And if I subtract 2 here, 2 to the 4 is 16. Okay. The thing though is that that's a good start. We want this to be able to work for any two numbers that I give you, right? Suppose that it wasn't, I'm looking at the far right side here, say 4 and 2 weren't the numbers, say it was, oh, I don't know. You had your YouTube posts seen by 10,000 people the first day, and then it grew by maybe 3 every day after, right? For those 10,000 people, for each of those 10,000 people, they share it to 3 other people, right? So if you go 10 minus 10,000 minus 3, it won't give the same effect right here. So I'll help you guys through this, but I just want to see if anyone said anything. So thank you, Marisa, for volunteering. So it actually looks like this. What we want is, let's use purple. We want it, they're growing because of this multiplicative state right there. Multiplicative state, I'm sorry. Right? So it's a multiplication, but it's not just mere multiplication. Right? It turns out that it's not only increasing by 2, it's growing exponentially, because you could see through the picture right here that one person spawned to 2, but then 2 people spawn to 4, and then it moves on forth. So you actually need a variable. In this case, I'm sorry, not a variable, an exponent. So in this case, it's 1 here, and then 2, and then 3. Now, why is that? 4 is our base. So you can think of these 4 as our base. So that's what we start with. That's why this 4 doesn't change. Notice how it's the same in all of them? Okay. It remains unchanged. It's the first day has moved on, and that's it. Now, it looks like it's growing by 2s because it's what we're multiplying by for each person. So how do you show multiplication without it getting super messy? It's with the exponents. The exception is the first one, where you actually have to make this one a 0 in the exponent. Because remember, 2 to any power is 0. I'm sorry, 2 to any power, anything to a 0 power is 1. That's what I was trying to say, right? And then you'll find out this will work for any day, right? So if this is supposed to represent, if the purple numbers are supposed to represent the days, right? It's supposed to, we'll be able to calculate how many viewership, if you will, we have for the post or whatnot on any given day, right? So the thing though is that something has to change here, because you notice the days are misaligned. So see how, we use a different color as well. Notice how this says first day, but I have a 0 here. This says second day, and I have a 1 here. This says third day, I have a 2 here, and this says fourth day, and I have a 3 here. So you can see we're off by 1. How do we fix that, right? We can actually manipulate the variable, and I'm going to show you that right now. Okay, so this is the story, if you will, the visual story behind this problem. Wait, I didn't write it out. Oh, right, because it's in, sorry, I should have said example 1 here. Example 1. This is our story, our visual story for example 1. Let me give you a couple more details so that it can kind of make sense more. So the above call this a definition right now. I'm gonna call it this social media growth can be defined as what? Alpha times beta. I'm just using Greek letters right here. It could have been any 2 letters. You could have put a C and a D or a J and a K, whatever, but I just ended up using Greek letters here. To the n minus, no, to the, I want it to be, hold on. To the I minus 1. I minus 1. All right, that's our equation, or expression, if you will. Expression is a better word. Okay, what do these represent? Pertaining to example 1, right, where alpha equals base day, right? So again, if I'm reading that question right there, it says, suppose for the first day, the social media post reaches 4 people. So alpha in this case would be 4. Why 4? It's how much our post reaches. How do we know it was 4? If you read the question, it says for the first day, and I wrote in italics, it reaches 4 people. Remember, your base following, that's one way to think of it as well, never changes, right? You have a base of things. Bases are like your foundation as well, right? They are intended to stay the same because they're foundational. Beta represents what I like to describe as the growth factor. Growth factor, right? In other words, how big or how much is it growing by every time you're doing an Instagram post or a Facebook post or a Twitter tweet or whatever the case may be, right? Facebook post, tweet, YouTube upload, going live on YouTube, whatever the case may be. In this case, it's 2. Why? Because it says that research suggests, that's your hint right there, by the way. Research suggests, if you ever see the word research suggests, you know you're doing this kind of problem. For my class at least, for each social media post published, it will reach 2 new people the next day and thereafter. So that means it will reach 2 new people each time, and it will continue that pattern moving forward. Last but not least, the I just represents whatever day you're talking about. Actually, I'll put it like this. Day or days in question. So let's try it, right? I know we already have the first 4 days written right there, and that doesn't help because it feels like, well, he just showed it to us already, so show me something that's different, and we will get to that. So for example, say, from first example, right? Still from example number 1. Right? You know that alpha is equal to 4, beta is equal to 2. And my question is, what about the 15th day? Right? And all you do is you go 4, which comes right here, times 2, which came from right here. And I asked for the 15th day, which means that you're going to go 2 raised to the 15 and then minus 1. So the minus 1 will be in every calculation there, right? It's only the I component that changes. So if you take the time to do this on your calculator, right, it just basically becomes 4 times 2 to the 14th. And that becomes what? 2 to the 14th. Whoa, that was wrong. So this answer becomes 65,536 people. So that's the reach, if you will, or reaches this many people. Now, I'm far from saying this is the proper growth rate of how social media works. It was just something that I read off of a mathematical modeling handbook when I first started at Columbia. And ever since I read it, I was like, hey, this is really cool. You know, it's like, it doesn't use a super advanced concept of math. It takes away some powers and multiplying and just a little bit of extra thinking to describe another way that can generate income, you know, and then maybe after so many people, you get like say 10 cents per person or something like that. And that's how you make money on a social media platform, whatever the case may be, right? But the idea is that this growth that we're having, it's growing exponentially, right? It's another way to grow other than linear or a variable or a constant that we've done so far, right? And this is to show you not only for a single day, the 15th day, but what happens if you have a series of days, right? Right? People, they generally post, people, influencers, as well as companies, right? Or communities even, they post to social media and they don't have it done just one day, right? They have it sometimes once a month or once a week or once every so many days. You know, they keep this, they're churning out content so that it keeps people engaged, you know. So obviously this is going to shoot really high if we get up to the 30th day, and that's unrealistic in terms of what happens in the real world. But at least the beginning part where it grows very slowly and then all of a sudden upshoots or upticks really high, you know, that's obviously true. And again, that's because it's exponential growth, right? It starts out really stable and then all of a sudden it just skyrockets, okay? Now, before I move on, what questions do we have about understanding what's happening here, whether it was visually or mathematically? Because this isn't going to be on every single problem, but your next homework does have a summation on it. And this is one half of understanding how the algebra works and then pulling in the summation and putting it together so it looks like a new income generator. So I'll just give people a moment to make sure that they, and then if they need to, I'll scroll right here so people can see everything that's happening. We're okay there? Okay. The video I posted about summations, that was just a quick refresher in terms of what a sum is. Obviously, you guys know what a sum is. Specifically, though, it has to do with what's called sigma notation, right? So if you haven't seen that video yet, watch the video. It's only 7 minutes long, maybe 6. If you want to watch to the very end and have a good chuckle, you can watch it to the very end. But do that, subscribe, all that jazz. And the idea is that if you have a regular sum where I say, hey, how many colors did I use in this example right here, right? You see purple, green, orange, blue, and black, right? You counted every color, 1, 2, 3, 4, 5, right? You one of each color, there's 5 colors, come together, and that's it. But what about sigma notation? Sigma notation tells you not only to sum or add, it tells you in a fancy way. And that fancy way is the following. It's just like this, right? That's what I have on the video, and we talk about this. And the important thing is that this piece right here is an algebraic expression. Algebraic expression. The reason mathematicians write a single I is just to show the simplicity of it, but it can be anything there, right? So there's that. And again, let me at least define these really quick. This I right here is what they call the lower limit, or starting point. And then the n on top is your upper limit. Or ending point. So that means that even though this is the most basic form of a sigma notation, you can have examples like this, right? This is basic form. You can have it where it can look like this, I equals 0 and 2 plus I quantity squared, right? That's going to be a calculation that exists in terms of summation, right? We're not going to do it, but I'm just showing you how the encircled I, the algebraic expression, it could be something simple as in, hey, just the number itself, or it can involve other things, or something like, say, this, starting at 0, n, and it can be something like I plus I squared minus I to the third, something like that, right? Where this is an entire expression. And what happens is that in the summation, you increase by 1 every time, right? You start with the lower limit, which I've written right here, the starting point, right? In these examples, I started with 0. So you start with 0 and you plug in a 0 everywhere you see that I, right? So in these two examples, this I goes right here. This I goes right there, and right there. Draw little arrows there. And then once you've plugged in your number and then do the calculation that's present, that becomes your value for when I is 0. And then what you do is you do the same exact thing over again, but with the next number. What comes after 0 comes 1. And you repeat the process, right? So this is just a notation. We'll do an example of this really quick, don't worry, right? But that's sigma notation. You can see the examples I have on the video too, but I'm gonna pick a different example altogether. I'm gonna pick an example, and also the example that's different from my textbook too, because I do talk about sigma notation there as well. I just wanna keep on giving you different things. So say we have, for example here, e.g., say I have a summation that starts at 1. We're going to go only to 3. And the expression is going to be, say, 4i. Okay? What this means is that this is equal to 4. Our first number, right, is 1, so it's 4 times 1. How do I know to plug in the 1 there? Well, my algebraic expression tells me so. And then we check to see if there's any other calculations here, which there isn't. It's just the 4 times 1. And then we're done. Now, this again, this sigma means summation, addition, right? So that means we have to put a nice little plus sign once we finish substituting everything in. And then we repeat the process. We got 4 again, 4 because of the algebraic expression, but now we're no longer at 1, we're at 2. So you plug in a 2 now, right? And then we check again, see if there's anything else that needs to be done with the expression right here. And there isn't. And then we add 1 last time. Why is it the last time? The reason is that now that since we're done with 2 and we're going to 3 now, that's our ending point right here. See, these have to match. That's how you know when it ends. Only after this is what most mathematicians show, only after you finish substituting in, then you calculate, because you don't want to do any minor calculations in between and accidentally plug in the wrong number or multiply a wrong number or whatever. So once we get to this point, then you can actually do the math, right? 4 times 1 is 4, plus 4 times 2 is 8, plus 4 times 3 is 12. So this summation, now that it has a systematic growth, right? In this case, 1 at a time, 1, 2, 3, as well as an expression to follow, in this case, 4i. This answer is, what is this? 8, 12 is 20, 24, right? Let's do one more. In fact, we'll do one more, and we're going to do it with, I'm going to go to only 2 this time because I don't want to wear you guys out. We're going to do it following this format right here, right? Social media growth, this weird little thing that I've created. So we're going to call it alpha, but this time it wasn't alpha, it was what? 4 times 2, yeah. 4 times 2, I to the minus 1, right? This means that this should give us not only the answers for day 1 and day 2, it tells us to add them up. So this is equal to, and normally the easiest way to go about this is just copy down all the things that don't have the variable in question. So 4 times 2. So we start at 1. So it goes into wherever you see I. So that's 1 right there. And don't forget the -1. And then that's it. And we break it apart because it's a summation. And we do the same exact thing one more time, except this time with the 2 plugged in. And now we have not only an algebraic expression that can represent the growth of our social media. If I want you to sum or add the first so many days, in this case, the first 2 days, right? We have a mechanism to do it without having to write everything out long all the time, right? So now you can simplify. This becomes 4 times 2 to the 0, which is 1. I'll write that on the note here, note. Any number, this is what I forgot to tell you briefly, any number raised to the 0 power is 1. All right. So that's 1 right there, and then this is plus 4. 4 times 2, 2 squared minus 1, which is 2 to the first, which is 4 times 2. And so we have our answer of 8, 9, 10, 11, 12. So you got 12 views in that first day. Okay. So we'll just scroll back here for a brief moment so you can see the sigma notation, which not only shows us how it can represent things that grow, whether it could be linear, exponential. This example is exponential, but whatever that growth can be. But the moment that we add the sigma itself, the sigma notation, it shows us not only to calculate, but calculate and add them together, add the results together. Okay, what questions up to here? Because now this is going to pull it all together and answer our problem number 2 in my Google Doc sheet. So I'll pause for a moment there. No questions here, okay. Nothing, something, anything? All right, so let's tackle number 2 now and do this together. Obviously, I'm not going to have you do this on your own. There's still a lot to pull it all together. And make sure that you also understand the vernacular and the language that I write this, because then it will match not only in class examples, it will match what's on the textbook. It will also match the examples in the textbook. It will also match the examples on the homework, the practice, and what will be your final. Okay? If I didn't mention it anymore or any way or anyhow, there's no more exams except for just the final. Okay, so nothing more to study or buckle down for other than the last exam. And then probably next, I'll start looking at people's homeworks tonight, see if people are on board, and then I'm going to make this homework due next week as well and see how people are, and then start talking about the format for the final, just making sure that people are on par of understanding and everything. I think that's what I'm gonna do, since I'm only going to be assigning 2 problems at a time, since the modeling problems are longer. I'll assign 2, and then I'll put the submission portal up immediately on Blackboard. So for those that turned it in advance, I can take a quick look and then just type out feedback and then give it back to you immediately. Okay? Because there's no real way for me to check, if you will. And normally when we have class time, I mean, I could do it. Yeah, I could do it where I can create an extra problem where during class, you guys can all sit and do it as well, but it's kind of meaningless because then normally it's easier in class where I stand there and I stare at all of you all in the eyes and I go, okay, what's the next step? Someone's going to tell me something, but over this online platform, not everyone's just keen on answering. So I'll figure that out. But yeah, I definitely need to see some way somehow that people are kind of understanding, sort of understanding or whatnot. But yeah, next Tuesday after we go over homework that involves summations for the models, I'll talk about the final format. It's basically going to be a cross between what you had for exam 2 and also uploading, because the easy questions that are supposed to help you answer the questions, those are going to be the ones where you type it out Blackboard and they'll be right or wrong. But then for models and stuff like that, I definitely have to have you take a picture and upload or something of that nature. Okay, so here's number 2. Social media division makes profit. So it says research suggests, right? Notice that when you hear that, you know it's going to be a summation. So write that in your notes or whatever you're scribbling on, that when it says research suggests, for this class, we're referring to something that is involved with summation. That it will reach 3 people the next day and thereafter once shared, right? I guess I should say once shared. Suppose for the first day of the month, the post reaches 10 people. And in addition, I tell you 10 cents is made for each person the post reaches. So the leading question, AKA make me the model, how would you represent the above monthly situation? Let's write down the details that matter. It says that research suggests that 3 people, it will reach 3 people. So you need to associate that the reach 3 people, that implies that your beta is equal to 3, right? This is again the growth factor. Then I tell you, suppose for the first day of the month, which I have to tell you, right? I have to tell you what happens or what starts on the first day. You can't do the problem otherwise. It says that it reaches 10 people. So first day, 10 peeps. This implies alpha is equal to 10. So you can think of this as initial. Okay, so what does that look like now? I'll call this purple. I'll call this blue. This implies that your model is the initial times whatever the growth factor is to the I minus 1, right? Initial growth. Now remember, this is a summation. We're not keeping track of just the first day. So then you need to add the sigma. I starts at 1. By the way, I'm going to write this here on the side. Our models always, start at 1 for summations. Okay. And it goes to some unknown number in the future, right? It's unknown because you don't know how many days in the month there are. It could be 30, it could be 31, it could be 28, 27, however many days. Sorry, not 27, 29, right? But the last thing was the fact that you said that you made 10 cents per person. So then you have to remember to throw this guy in parentheses and multiply by 0.1, right? 10 cents is 1/10 of $1, so it's just 0.1. So that's our model right there. Whoa. There we go. Right? You have this base 10 times 3 to the I minus 1. Where did that come from? That came from the introduction of this definition of social media growth can be defined as, for this class at least, and I list the variables there. We know it's a summation because from the problem, it's not happening a single day. The assumption that is it's happening for the month, and then there's going to be months following after. That's why we have all those follow-up questions. Last but not least, you have that 0.1 in front because you're going to make money, right? You're going to make 10 cents per person this reaches. You can't just have a record-breaking audience and then all of a sudden not monetize from it. So that's our model. It's the most basic form of it, right? The ones that you have for homework will be a little bit more involved, okay? So that's our model. That's the leading question. This is also your base model. That's another way to think of it, base model. And then now we can answer the questions. Let me scroll down to right here. Here's question 1. These are calculating questions, the first 2, right? It says how many people are reached within the first 5 days, right? And how much was made? Notice how I wrote in italics the first 5 days. And the reason is that I want you to do the summation from 1 to 5. And that's why that is an N on the top, because you don't know what number you're counting up until. Then you follow these same numbers here, 10, 3, 0.1. And you do this 5 times, right? This is what it looks like. I would not worry about that 0.1 just yet. I would save that for the last. So now you're going to go 10 times 3 to the 1 minus 1. You know what? Let me do those counting numbers in a different color. 1 minus 1. Plus. Why plus? It's a summation. Summation means to add things up. Not to arbitrarily add, but add one at a time. That one at a time being same numbers here, 10 times 3. Now we increase by 1 times 2 to the minus 1. And then 10 times 3 to the 3 minus 1. Everyone's starting to see the pattern now? Normally it takes a couple of visual takes of this to understand what's going on, but this is what we wanted to get at. And of course, I couldn't make a YouTube video of just doing this because it would take so damn long. That's why the video that was made was just a super rudimentary version of it so that people are aware of what sigma notation is. And then now we actually bang out the details in terms of modeling, right? Because I wanted to make those videos relevant to any viewer that's looking for a summation. But now when we get to the modeling, we have this. And that also means that now I can make another video where it's another mathematical modeling, but instead of talking about, you know, something that's linear or cost revenue profit or whatever, I can make it based on summation, all right? So there's that. So then now you just take the time to crank out these numbers, right? So this is going to be 10 here. And this is going to be 10 times 30. And then 30 times 3, this should be 90. And then 3 to the 3 is 207. So that should be 270. And then this I can't do in my head. 10 times 3 to the 4th, which is 810. Now, if you add all these up, what does this represent? You must remember that it represents the people first, right? 810 plus 270 plus 90 plus 30 plus 10. So this is 1210 what? 1210 people that you've reached. Now, how much did you make? You made this times 0.1. This represents, move 1 decimal place over, $121 made. So those are the two questions that are answering for not only question 1, but this is question 2. No, sorry. Not yet. This answers both questions for question 1, right? How many people are reached within the first 5 days? It's 1210 people. And then how much money was made from those 1210 people? $121. Assuming that I did that right. 1210 times 0.1. Yeah. All right. Question 2, I'm going to move this down now, is another calculating question. But what's unique about it is that I asked you how many people are reached on the 15th day. So that means the 15th day only. I should italicize that as well. So I'm going to italicize that. And it's to give you that pressing or that urgency that I'm only asking for a single day. So if you're asking for a single day, you don't need a summation. You just need no summation, right? For single day. Which implies the same exact base here, 10 times 3, but this time, since it's the 15th day, you plug in a 15 there, okay? And that's the nice thing that we have this -1 in the exponent, because it allows for the summation where if you plug in a number, it represents what actual day you have. Unlike at the very beginning, my visual example right here, notice how it was first day, but the exponent was 0. Second day, exponent was 1. Third day, exponent was 2nd or 2, and so on. It was off by a day. This -1 in the power compensates for that. So that's why I teach it that way. So that's 10 times 3 to 15 minus 1. So we got to figure out this number. It's going to be big, by the way. It's going to be quite large, actually. So this reaches 47,829,690 people. And then that means that you made $4,782,969. I wish, right? So you can see it's multiplying by 10 cents or 0.1. The decimal point just moves over. So these are your two answers right here. Okay, so this is question 2. So that's the difference between asking for the first so many days, in this case 5 days. By the way, if this is going to be on the final, I'm not going to ask you to do a huge number of days. It's going to be something simple like 5 or less, because as you can see, it gets tedious once you go so many days out. But you definitely want to be able to answer for a single day, because that's just a single calculation. However, I will also make sure that the final doesn't have a number that's so big that it kind of destroys or demolishes your calculator, making the number way too big, and then you're going to have trouble recording it, because sometimes it'll use what do you call scientific notation. So don't worry about that, right? So don't worry if, oh, is he going to make us do so many numbers to add up? No, it's just to show you what a summation does when it means first so many days. And then when you calculate for a single day, it's not going to be an absurdly large number, because then if it's too big, then you have to worry about scientific notation on your calculator as well, okay? Now, what about these last two questions, number 3 and number 4? These are, again, of the manipulation, but also a little bit of theory, though, right? So it says, suppose for the second month, the growth of reach, quote unquote, stays the same, right? So that means that I'm just doing times 0.1 so people will remember here. So that means that for the second month's model, I'll write that down here. I'm gonna scroll up a little bit too. Second month's model. They're saying the growth stays the same. That implies that this 3, the growth factor, is going to stay the same, right? Suppose for the second month, the growth of reach stays the same, but the first day, the post reach doubles, reaches, wait, what the hell am I trying to say? Reaches double numbers, or reaches in double numbers, or however the hell you want to say it. I don't know, I was just trying to be enthusiastic about it. But instead of 10, it's going to reach what? What's twice of 10? It's going to be 20, right? How does the model change and what is the overall effect? Well, if 3 stays the same and 20 increases, and now I fill in all of the details that would make our model, what has happened compared to this versus the base model, which is right there? The first day has changed. It has doubled. It went from 10 to 20. So that's the model right there. The effect is that overall model increases in viewership. Or I'm just going to say in reach. I want to be a little vague here because I don't know if it's going to be YouTube viewership or Instagram following or TikTok dancing or whatever. In reach, right? Do I know how much it grows by? Not necessarily, because you don't know how your growth is going to be. I mean, the easiest way to think about it is that it's going to double because it went from 10 to 20. But the idea is that even if you don't know what the numbers are, or you don't know how many days you're going to, like say for example, the base model, you go only to 10 days, but this one you're going to go to 5 days, right? You don't know what the actual result will be until I give you some kind of calculating problem to do. But what you do know is that the overall effect is an increase effect. Why? Because our growth is the same, but our base, our starting point of 20 people has what made our lying foundation a lot higher. So it'll grow at the same rate. It's just that we reach more people from the beginning, right? Whereas question 4, I ask you, A, so we're on the 3rd month's model now. Whereas the 4th question, it says, suppose the 3rd month research suggests, right? That's how you know when I'm talking about the growth. Research suggests a published post reaches 4 new people the next day and thereafter, right? So that means that now your growth factor is a 4 instead of a 3. And then I said, suppose for the first day, your published post reaches 1 person, but then I gave you another change as well. I told you now instead of 20 again, you know, say it's like virus related, only 1 person is interacting with your company in terms of social media outlet. What does it look like now? Well, those are the numbers changing, but everything else is the same because it follows the model, right? Summation, and you're being paid by 10 cents for each viewer, right? If I told you if the number of cents that you were paid for each viewer changed, you would change that. But the whole idea of, I'm gonna just draw little stars here really quick. The whole idea of the summation here in black, as well as the fact that the multiplication and the power, those do not change unless explicitly told. And even if it does change, it doesn't change drastically, right? Because if you look at questions 1 and 2, question 1, the n or the upper limit changed to 5. So you know you do it 5 times. The second question, there is no summation. So you don't even use it all together, but the exponent does change for whatever day that it's representative of, in this case, the 15th day. So you can see that the base form of the model is always the same, as well as these new mechanics I'm teaching you about exponential growth and about summations and everything. But things that do change are the things that matter. First day of the post, you know, the growth of it, so on and so forth. I didn't change the money you made per view or per reach or per person in this case, keeping it 10 cents all the way. But now you have an idea of what it looks like when it can change. All right. Oh yeah. All right. Let me just take a quick look at my textbook to make sure I'm not missing anything weird. All right. So that's it for today I have for you, right? And because I didn't know how long it was going to take, that's why I only made one example. But as you can see, look at that. We shaved off 20 minutes because you're not sitting here watching me write. So I'll probably create more examples for the lectures to come. But I don't want to exhaust all the problems I have written down because it takes me a little bit of time to write the new problems. So your homework now is the same page, page 30, but now the next few problems. Homework number 7 now, which is our second modeling homework, right? Is just page 30, and it's now numbers 3 and 4. So 3 is a summation again, and 4 is just a harder version of an algebraic model. But a couple things I do want to add. I know that it may have seemed a little bit wonky at first to learn something that felt new. I know people have seen summations before, but maybe you have not seen sigma notation before. So again, I thank you for your patience as you're going through that and encourage you to ask questions, even though you may not feel like shouting out in the middle of a lecture. It's the only way I'll know. That's 1. But 2, hopefully you realize that even though this one may feel a little bit more theoretical, you can see there's a lot less physical writing and work into it, if you notice, right?
You just got to figure out the summations, figure out the numbering in terms of how and growth and other things of that nature, but there's not a lot of calculation. Whereas cost, revenue, profit, you got to find the slope and then the equation to find the profit function and all that other stuff too. Now, this is an easy example where I don't have other expenses, but the expenses, again, can only be so limited, right? A variable to pay your intern, a lease of a website, which you're going to see on your homework right there. In the textbook as well, I do have an example problem of a summation. However, I didn't finish writing out the answers yet, so I just got to do that too. But for the homework, those answers are already done. So this is just if you need more examples of this type of model. Okay, so takeaways, right? You have your homework. You have learned, this is the absolutely last new thing you're learning. You learned a new way to create income or generate income specifically through exponential growth via summation, and it's supposed to mimic social media growth, right? These summation-based models are easier in terms of less physical writing, but more critical thinking, so more theoretical. And the last thing I need to give you is that the homework answers are already in the bottom of my textbook in the appendix section, but example 4 in my textbook that has a summation, just in case if you need to see more examples, I need to type out those answers as well as look through people's homework and give you feedback on that as well. All right? What other questions do you have for today, if any?